In this lesson, let us introduce data mining by looking at real-world COVID-19 trends and related datasets. Week 1 to 2, Data Mining Introduction with COVID-19 Data. Welcome! Let us explore real-world data mining using Python. We will track COVID-19 global cases, learn basic analysis, and visualize changes over time. You will also get first-hand practice loading datasets like Titanic and supermarket sales. By the end, you will be able to analyze public data and see trends with simple charts. Running the cell now. Let us start by preparing our Python environment for safe, reproducible analysis. Let us prepare our Python environment. We want to hide scary warning messages and import tools for data and charts. This comment tells us we will stop warning messages from showing. We import the warnings module, which helps us manage Python warnings. We turn off all warnings with this line so the screen will be clear. Now, we import two essential Python libraries. Pandas lets us load, explore, and change data. Matplotlib.pyplot is for making charts. We load pandas to handle data tables. It is like Excel but in Python. We load matplotlib.pyplot. This lets us make line charts, bar charts, and other simple graphs. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This initial code sets up our environment by importing essential libraries for data analysis and visualization, like pandas and matplotlib, while also suppressing warnings to keep things clean for beginners. Notice there is no output here. That's expected because this step is about preparing the tools we'll use to explore COVID-19 data in the upcoming lessons. This foundation ensures smooth, focused learning as we dive into tracking global cases and visualizing trends. Your environment is ready. Let us begin with our first real dataset. Our first hands-on step is to load real COVID-19 case data. COVID-19 global cases, data setup. We will use daily worldwide COVID-19 case data published by Johns Hopkins CSSE. This data helps governments and researchers track the virus over time and by country. Running the cell now. Next, let us load the dataset and take a peek inside. Let us load the COVID-19 data into pandas and check what it looks like. This is our COVID-19 data setup cell. We import pandas so we can handle the table-style data. We specify the URL for the COVID-19 confirmed cases file, hosted by Johns Hopkins CSSE. We read the data into a data frame called df_COVID. A data frame is like a spreadsheet in memory. We print the shape of df_COVID to see how many rows and columns we have. We print the top 3 rows so we can see what the data looks like. Running the cell now. This output shows the initial COVID-19 confirmed cases dataset with 289 rows representing regions and 1147 columns representing dates from January 22, 2020, through March 9, 2023. Notice the first few location columns, province, state, country, region, lat, long, followed by daily cumulative case counts, illustrating how the data is structured for time series analysis. This setup is crucial for tracking COVID-19 progression globally over time by country or region. Practice: try changing URL to a different local CSV if you have one. If you are learning on YouTube, pause to play with your city or country data. Before analyzing, we want to know what information is available. Basic exploration, columns and missing data. Let us check which columns are present and see if we have missing values. Understanding the structure is the first step in data cleaning. Running the cell now. Let us do this basic exploration step together now. We will take a quick look at what information is in our COVID-19 dataset. This comment is a reminder that we want to see column names and check for missing values. We print out the list of the first 10 column names. This helps us see date columns and location information. We check if any value is missing using pandas isNull and any. This answers whether our data is complete. Running the cell now. The output shows the first 10 columns of the dataset, revealing both location info, province, state, country, region, lat, long, and date-based columns for COVID-19 cases. The presence of true for missing values alerts us that some data is incomplete, highlighting the need for cleaning before analysis. This step confirms what data we have and flags potential issues to address early on. Try printing all columns by changing 10 to just a colon if you are curious. YouTube tip: pause and count how many date columns there are. Now, let us see what unique country names are present in this data. Simple data cleaning, working with country names. Country names in public data are not always consistent. Let us inspect unique country entries next. Running the cell now. We will do this with a single command in pandas. Let us list and count unique country names. This step prepares us for grouping data later. This comment tells us we want to see the set of countries in our COVID-19 data. We print the first 10 country names, alphabetically sorted, to catch any naming oddities. We also print how many unique countries there are. This is useful to know our dataset's global reach. Running the cell now. Here we see the first 10 unique country names sorted alphabetically, confirming the variety of entries in the country or region column. The total count of 201 unique countries highlights the dataset's breadth, emphasizing why it's important to check for consistency before cleaning or analysis. This step ensures we understand the scope of variations we might need to standardize. See if your country appears in the sample output. Try scrolling through the whole list in your own notebook. Our data has dates as columns, which is hard for some analysis. Let us reshape it for easier time series work. This comment explains we will convert column-based dates to a better shape for analysis. We save all column names after the fourth as our date columns. We use pandas melt to turn the table long so one row equals one place on one day. This step sets us up to plot trends over time. We convert the date column from text to a true pandas datetime object, making it easier to filter and plot dates. Running the cell now. This code reshapes the data from wide to long format and converts the date columns into a usable datetime format. Notice how the date column now contains standardized datetime values, making it easier to analyze time trends. This step sets up the data for consistent country name inspection and further cleaning by aligning date entries for each country and region. Now our data is tidy, with each row showing a single day's case count for a location. It is time for our first real-time series plot. Visualizing COVID-19 total cases for a country. Let us plot how total COVID-19 cases have changed for one country. This helps spot waves and important events. Running the cell now. We will start with Italy, but you can pick any country you like. Let us make a line chart showing how cases changed in Italy. This comment says we are plotting a chart for Italy. We set country to Italy, but you can choose any country later. We filter our big table for rows from Italy, then add up confirmed cases by date. We make the figure a bit wider for clear viewing. We plot a line with dates on the x-axis and the number of cases on the y-axis. We give the plot a title that shows which country we picked. We label the left side of the chart as confirmed cases. We label the bottom as date. We add a grid to help see changes. Finally, we show the chart on the screen. Running the cell now. The line chart shows the total confirmed COVID-19 cases in Italy over time, revealing clear trends such as the initial rise and subsequent waves of infection. Notice how the date on the x-axis tracks progression, while the y-axis values highlight the magnitude of cases, helping us understand the timing and scale of outbreaks. This visualization fulfills the lesson's goal of identifying important pandemic events through a country-specific case trend. Try switching to another country, for example, United States or India. On YouTube, take a moment to notice when the biggest increases happened. Now you can type the name of any country and create your own plot. This comment gives a prompt for hands-on plotting. We ask the user to enter their chosen country with the input function. This helps you practice interacting with data. We filter the long-format data for the user's country and some cases by date. We make a new wide plot window for easy viewing. We plot the chosen data in orange to tell it apart. We set a title to show which country the user picked. We label the y-axis as confirmed cases. We label the x-axis as date. We use a grid for readability. We display the new plot. Running the cell now. The plot displays the trend of total confirmed COVID-19 cases over time for the selected country, showing how the number of cases accumulates day by day. Notice the shape of the curve, whether it rises steadily, has sharp waves, or plateaus, which reflects key phases in the pandemic for that country. This visual helps us identify major outbreaks or control periods, fulfilling the lesson's goal of using time series plots to understand pandemic dynamics. Great! Practice typing country names exactly as printed above. For more, try abbreviations or misspellings to see what happens. Let us switch from total to monthly new cases, which shows COVID-19 waves better. Mini exploration, monthly new cases. Viewing new cases by month helps spot waves easily. We will compute monthly new cases for Italy. Running the cell now. Let us summarize and plot the monthly pattern. Now let us process and plot monthly new COVID cases for Italy using a bar chart. This comment says we are making a monthly cases bar chart. We use pandas difference to calculate new daily cases, then resample to some new cases for each month. We expand figure size for clearer bars. We plot the bar chart with months on the x-axis and new cases on the y-axis. We title the chart for clarity. We label the x-axis as month. We label the y-axis as new cases. We rotate month labels so they fit better. We add horizontal grid lines for better reading. We use tight underscore layout to avoid cut-off labels. We show the finished chart. Running the cell now. This bar chart shows the total new COVID-19 cases in Italy for each month, calculated by summing daily case differences. Notice the peaks and valleys that correspond to waves of infections, illustrating how monthly aggregation smooths daily fluctuations and highlights broader trends. This visualization confirms the code's intent to easily identify periods with high new case counts over time. Pause and look for biggest outbreaks. Try this for more countries in your code. Let us compare COVID-19 confirmed cases between Italy and India for the year 2020. This comment tells us we will plot for two countries at once. We set first country as Italy. We set second country as India. We filter for Italy up to end of 2020 and some cases by date. We filter for India in the same period and some cases by date. We prepare a wide plot window. We plot Italy's trend in red. We plot India's trend in blue. We give a chart title saying what the chart shows. We label the x-axis as date. We label y-axis as confirmed cases. We show a legend so users can tell which line is which. We display the plot. Running the cell now. This plot compares the cumulative confirmed COVID-19 cases in Italy and India throughout 2020, letting us observe differences in the timing and scale of outbreaks. Notice how Italy's curve rises sharply early in the year, reflecting the initial wave, while India's cases increase more gradually later on. This sets the stage for our lesson on monthly new cases by highlighting why breaking down data by month is crucial to spot waves clearly. Try changing country 1 and country 2 to other nations from your list. Does the peak come at the same time? Let us save our reshape data for analysis later or to share with others. This comment tells us we are exporting data. We export the long-form data frame to a CSV file called tidy_covid_data.csv without row numbers. We print a message so we know the save worked. Running the cell now. This message confirms that the cleaned and reshaped COVID data has been successfully saved as a CSV file for future analyses. Exporting the data ensures we can easily reload and work with the monthly new cases for Italy without repeating pre-processing steps, streamlining our exploration of case trends over time. This makes it easy to reload the tidy data next time. Let us practice with a second real dataset used around the world for teaching analysis, Titanic. Introducing another dataset, Titanic passengers. The Titanic dataset is famous for teaching data cleaning and survival predictions. Let us load a sample and compare its structure to COVID-19 data. Running the cell now. We will see if there are columns that match or differ from our first dataset. Let us load the Titanic dataset into a Pandas data frame and take a brief look at it. This is our Titanic data setup. We import Pandas to handle the data. We specify the location of the Titanic CSV file. We read the CSV into a new data frame called df_Titanic. We print its size, showing the number of passengers and columns. We preview the first 3 rows to see what information each row holds. Running the cell now. The Titanic dataset contains 891 rows and 12 columns, representing individual passengers' details such as survival status, class, age, and ticket info. Notice how the sample preview shows a mix of numeric and categorical data, highlighting key features we'll use later for cleaning and predictive modeling. This initial glance sets the stage for comparing the dataset structure with COVID-19 data and understanding its variables. Notice columns like name, sex, age, and survived. How do you think these could be useful for prediction? Let us check if any age values are missing. This step is vital for data cleaning. This comment helps you focus on finding missing data. We count how many age entries in the Titanic data are blank by checking with ISNL. We print out the total number of missing age values. Running the cell now. Here, we see that the Titanic dataset has 177 missing values in the age column. This highlights a common data cleaning challenge, handling incomplete information, which you'll often need to address before building predictive models. Comparing this to COVID-19 data, you can start to appreciate how missing data affects analysis and the importance of identifying it early. Missing data is a common challenge you'll face in almost every data science project. Practice, try checking missing values for other columns. Let us summarize the progress you have made. Recap what we learned. We practiced loading real-world datasets and transforming COVID-19 daily data for time series charts. You learned to clean, reshape, visualize, and compare trends across different nations. Missing data is everywhere, so we always check for it, as we did with the Titanic dataset. Running the cell now. Next, try practicing with data from your own area or with your favorite dataset. Congratulations on completing your first real data mining session. Thanks, and next steps. Want more project guides like this? Practice with our notebook and subscribe for updates. In the next part, we will try grouping and comparing data from retail and Airbnb. See you next time. Running the cell now. YouTube call to action, like, comment your country below, and subscribe for more beginner-friendly data mining walkthroughs.